Hi guys. Today, um, I want to talk about one of the area where many students have problem. Now, we are talking about strong student in year six, and they are supposed to be able to do calculations. So they need to be able to deal with the decimals. They need to be able to deal with fractions. Now, what I find is that many students they don't actually learn how to handle fraction really well, and as a result, they struggle to do the calculation. The purpose of the video today is to look at a fairly hard problem, and the problem requires students to do very intensive calculations. And they need a variety of skill to deal with fractions. What I find is that many students at year 7 and 10 are still incompetent when they do the calculation. So the question is, are you a competent computer? A person who can do the calculation and get them right. And many students, they don't have the foundation at year 4 to 6. And they never really try to fix this problem in a higher year. So, by the time they get to year 7 and 8, and they still have problem. So the consequence of this issue is that many students, they have very poor speed. It takes them a long time to do the calculation, or they make very silly mistakes. All right, so here is a problem for year 6. Now, what I like you guys to do is to pause the video and try to solve the problem. So you get an idea um, about the sort of calculation that you have to do. Now, I know, at year 6 or year 5, um, many students will find this problem really, really hard because it involves very hard problem solving. It requires you to know about proportion, and it requires you to do a lot of calculations. Okay, so now, guys, you can pause the video and try to solve the problem. Now, apart from this, at the end, um, like after you finish solving the problem, I want you to give a comment to think about what you did, what you struggle with, and give a comment for the video. Okay. Um, Now I'm going to move on, and I'm going to show you how the problem, could be solved. And I show you all the calculations and the skill you need to do in the calculation to give an idea that it's actually very difficult for a year 6 student to be able to solve this sort of problem, perform all the calculation, and get them right. Okay. Okay, so let's have a look at it. Now, here we have a container of red dye weigh 2.27 kilo when it is a third full. And you have another identical container, and it weighs 4.7 kilo when it is 6 out of 7 full. What is the weight of the empty container? Now, you see, the writer of this question made it a little bit harder by giving you the decimal numbers. All right. And the problem does not look really easy because you have to deal with fractions. Okay. So what I propose is the best way to deal with this problem is to draw a picture to give an idea about the fraction. So that's what I'm going to do. Okay, so first I'm going to draw the two container. So let's do one, and we'll do another. Now they're supposed to be identical. Okay. Now The first container is a third full. So we are going to have to indicate that. So roughly a third. So I'm going to just draw the line here. That give me a third. Now the other one's supposed to be 6 out of 7 full. So I'm going to draw the line. Now I don't have to be completely accurate. Okay, so I'm going to write down. So that is 1/3. And this is 6 out of 7. Okay, so they are filled with red paint. Red dye, I'm sorry. All right. Now, let's see how the problem should be solved. So they give you the weight of container 1. So let's say this is a container 1, so I say C1, and this container 2, I say C2. And the weight of the entire container, that's 2.27 a kilogram. And the other one is 4.8 a kilogram. Now, the fact that the two containers are exactly the same, identical of the same size. The only difference is the amount of paint inside. And they give you the weight. So you can say that the way to solve the problem is to find out the difference in terms of the weight of the paint. And also to find out the difference in terms of the capacity, how much of the capacity of each of the containers have been occupied by the paint. So you see, if you do a subtraction, now the difference in terms of the level of paint is like that. So you can say that if you subtract the weight of container 1 from the weight of container 2, you will get the difference in terms of weight of the paint inside the two containers. Now, also because we know how much of the container has been occupied, we can find the difference in terms of the volume of the dye inside as well. Now, that will help us to solve the problem. Okay, so the calculation is something like this. So you have the difference in terms of the weight of the paint is 4.8 kilo. You subtract 2.27. Now that gives you the difference in terms of the weight of the paint. Now the difference in terms of the volume is going to be 6 out of 7, and you subtract 1/3. Now, so you see the first skill you see is the subtraction of a decimal number. And the second set of the skill is the subtraction of a fraction. All right, so let's try to do that. So let's try to do 4.8. We take away 2.27. Now, subtraction of the decimals, we need to make sure that point over point, they match. Now, so I would add a 0 into the top number, so I have everything matching. All right, now try to take 7 out of 0, can't do it. So I'll try. So 8 become 7, then move 10 over. Okay, so we have 3, and then we have 5, and we have 2.53. So the calculation equal to 2.53 for the difference in terms of the weight of the dye in there. Okay, the subtraction of the fraction. Let's see how we should do it. So 6 out of 7, take away 1/3. The denominators are different, so we have to find a common denominator. Now look at it. 7 and 3, they are prime numbers. So yes, the common denominator is just, the product of the two. So we have 21. So 21. Now we convert the fractions into equivalent fraction. So out of 21, so we have 18 at the top for the first, and the second one is going to be 7 out of 21. Now, so the result is 11 out of 21. Okay, so now we write it. So 11 out of 21. So I have done the calculation. Now, the next bit is to figure out how I can get the weight for the paint in container 1. Now, if I can get that, then I can subtract that from the total weight of the container and the paint, and I'll get the weight of the empty container. All right, so I'm just wipe out the calculation to make room so I can do the calculation. Now it's time to set up a proportion. Now what I want to do is to find out the weight of the 1/3 paint inside container 1. So what I can set up is this. 11 out of 21 is the difference in terms of the volume of the paint between the two. Now that match with the difference in terms of weight, which is 2.53 a kilo. So now what I can do is I look at in container 1, the volume of the paint is 1/3. So I put 1/3 there, and that will match with something I don't know. Now, if I can work that out, and I know the weight of the paint inside a container 1. Okay, so the operation is going to be, I'll take 1/3 here, and I divide that by 11 out of 21 to see how many times. And then I can time with the weight on the right hand side, and then I'll get the answer. So the calculation is 1/3 divided by 11 out of 21 to see how many times. Okay, so we need to do the operation. And then whatever we get, okay, whatever we get out of that, we can just time that with 2.53, and that will give the answer. Okay, so let's do the calculation. The division become, I'm going to do the working out. So 1/3 divided by 11 out of 21 is the same as 1/3 times with 21 over 11. Now cancel down, I can cross out, divide by 3, I get a 7. So the answer is 7 out of 11. Okay, so that is great. So I'll just put the answer in. So 11 out of, so 7 out of 11 times with 2.53. All right, now if you have a calculator, it would be easy. But again, you are not supposed to use the calculator. So you have to do the calculation, right? So that's 7 times with 2.53, then divide by 11. Okay, so that's what I'm going to do. Okay, I need to free up some space so I can do the calculation. Okay, so 2.53 times with 7. I have to do that. 7 times 3 is 21. I keep 2. 7 times 35 plus 2, 37. I keep 3. 7 times with 2 is 14. With 3 is 17. And 1, 2. So 17.71. Now that needs to be divided by 11. So I have to do 17.71. I have to divide by 11. So I get 1 time. 1 time 11, 11. I subtract. I get a 6. Now the dot go in. And then 7 go down. So I get 6 times. So 6 times, that's 66. I get 1. they're going to go down. So I get 1. So 1.61 now. So that equal to 1.61. All right, now, so 1.61 is the weight of the paint in a container 1. Okay, I free up some more room. Now, to find the weight of the empty container, I have to subtract the paint from the weight of the entire thing. So for container 1, we have 2.27. Now we need to take 1.61 away from it. So get 6. Now, yeah, can take that. So try 1. And so now we have a 6. And all right, so the answer is 0.66. Now, okay, guys, I have solved the problem, and the answer is 0.66 a kilo is the weight of the empty container. Now, as you can see, there have been a lot of calculations involving a decimal and a fraction. Now, what I find is that a lot of the students, even if they know how to solve the problem, they make silly mistakes in the calculation. And that simply means that the skill to do calculation is so important. And the student have to be competent in doing that. And if they are competent in doing the calculation when they are in year 6, they should be able to move on and, become competent in the calculation later when they go to high school. Unfortunately, many students, they simply do not have the skill to do the computation. And when they get to high school, they never really try, to improve it to the level where they can actually do it right. Now, at high school, you have a calculator. Now, I mean, some people say that, oh yeah, we have a calculator. Yeah, so we might just as well use it. But the truth is, if you want to become any good, you have to be able to do the calculation by hand. You have to. Now, all the exams for scholarship, the exam for selective school, and all the aptitude kind of exam later when you do in later years. For example, if you are in year 8, year 9, and you still want to sit the selective test again to go to selective school, you have to be able to do the calculation by hand. They don't let you have the calculator. So this problem and the set of calculations you need to be able to do here help you to know how good you are. Now, if you can solve this problem, you can do the calculation and get the right answers. That means you are pretty good. Now, if you can't, and I bet a lot of students in year 5 and 6 will fail and make silly mistakes even if they know how to solve your problem. Now, think about it and think about your ability to cope with the intensive calculations that you will face. Now, this is the difference between a strong student and a normal student. When you go to selective school tests or scholarship tests, you have to do the calculations and you have to get them right. And they keep on testing the student all the way to the higher years. Now, even if you are in year 7, year 8, year 9, and you want to go to a selective school, you have to do the same thing. They still test the same thing. You have to be able to do the calculation. You have to do the problem solving. And in a problem, there are so many calculations that you have to do. And you have to get them right. And you have to be able to do that without a calculator. All right, so think and reflect on my message. And I love to see your comment.